Namaste children, how are you? You are eagerly waiting for science class, right? I welcome to Samveda e-learning program. This is the session number 2. The important learning points of today's session are: the first point, versatile nature of carbon, saturated and unsaturated hydrocarbons, then chains, branches and ring structure formed by the carbon, then functional groups, homologous series. These are very important concepts dealt in the session. The versatile nature of the carbon, why it is unique? The nature of the covalent bond enables the carbon to form a large number of compounds. In a single chain, thousands of carbon atoms may be there. And also carbon exhibit very important properties, that is the property of catenation, chain formation and tetravalency. 4 valence electrons are there. It will form 4 bonds with monovalent elements. Carbon has this property and it has the property to form the bonds with other atoms of carbon and also with other elements. This gives rise to a large number of molecules. This property to form huge chain by sharing the electrons with its own atom is called as catenation. Now you are seeing here the beautiful animation shows how the carbon is linked with its own atom. Now catenation compared with other elements, silicon, phosphorus, sulfur and other elements also exhibit the catenation property, but silicon forms the compounds with the hydrogen which have chains up to 7 or 8 atoms. It is the limited, but for the carbon innumerable number, millions may be there in a chain, and also those compounds are stable for hundreds of years. But these compounds are very reactive, that means unstable, but carbon compounds are stable. Here you are seeing this is the red phosphorus that is used in matchstick, right? Now this is the silicon hydride, a ring structure, and this is, what is this? This is the sulfur S8 molecule. Now let us see what are the different types of catenation formed by the carbon. The first one is open chain, that is the straight chain. The next one is branched chains. Due to this branched chain, we are able to see isomerism. Here is the branched one. See here how the branching is formed by the carbon. Minimum carbon required to show the branching is 4. Here I am showing the 5 carbon chain with a branch. Now this is the ring structure. This is the type of catenation called ring structure. Here you are seeing cyclohexane, this is the benzene, very wonderful compound. See here, the bonds are moving. Cyclohexane and benzene, the compounds of carbon which are having only single bond between 2 adjacent carbon atoms, only single bonds, are called as saturated compounds. So example, hydrocarbons called alkanes. Alkanes are the class of compounds with only single bonds. Now unsaturated compounds, the compounds of the carbon having double or triple multiple bonds between 2 carbon atoms, they are called as unsaturated compounds. Example, alkenes, this is the double bond between 2 carbon, it is called as ethene. And alkynes, 2 carbon in between the two carbon, you are seeing here 3 lines, right? It is ethine. Now, the stability of the compounds, this is very, very important aspect which made carbon as unique. Carbon-carbon bond is very strong and it is stable also. That means these compounds stay in the nature hundreds of years. This gives us the large number of compounds what we are seeing in the nature. Here the carbon and carbon, they are linked to each other and many carbon atoms are forming huge chain. This is the uniqueness. Here we are seeing the large number of compounds with many carbons are linked to each other. Stability of the carbon compounds compared with the others, you can easily compare because carbon can form strong bonds with its own carbon atoms and also with other elements like hydrogen, oxygen. These are also very strong bonds because of small size. The small size enables the nucleus to hold the shared electron pairs very strongly. So, shared pair of electrons are held strongly, but in some other elements, what happens? The bonds are weak because the bond length increases means electrons are far away from the nucleus, hence less energy is sufficient to break, hence they are highly reactive. But carbon compounds are stable because they have very strong bond between them and high energy is required to break them. The bonds formed by the elements having bigger atoms are much weaker because they have larger bond length compared to carbon compounds. Now, another unique property, that is the tetravalency. Carbon is capable of forming the bonds with 4 other carbon atoms and they also form different elements like hydrogen, oxygen, fluorine, nitrogen, chlorine, sulfur and so on. So, carbon can link with its own atom different atoms of different elements. Here you are seeing the tetravalency of the carbon. Carbon has 4 valence electrons, so it can form bond with many elements. Now let us see hydrocarbons. What are you seeing? This is the hydrocarbon. This compound is formed by only hydrogen and carbon. Hence the binary compounds of hydrogen and carbon are called as hydrocarbons. Here you are seeing double bond, triple bond and single bonds. All these are hydrocarbons only. That means alkane, alkene, alkynes are example for hydrocarbons. Identify this molecule. This is the electron dot structure of methane. Already I think you practiced this one. Very important structure. You should not forget electron dot structure of the elements. This is the saturated hydrocarbon. Why? Yes, you are right, because they have only single bonds between carbon and hydrogen. Now this is the electron dot structure of what? Ethene, means double bond. How to write this one? In the first step, you have to write the carbon chain. How many carbons are there? 2 carbons. So write 2 carbons first. Yes, I think you are practicing along with me. Are you following me? I hope you are. Try to draw the structure of ethene. Yes, 2 carbons wrote. Now a single bond is drawn between these. Then equal distribution of hydrogen atoms. How many are there? 4 are there. Let us distribute. Yes, each carbon gets 2 each. Now let us draw the bond between hydrogen and carbon. Yes, completed. What left? Now check the tetravalency. Check the tetravalency of the carbon, whether it is draw one more bond between the carbon and carbon to satisfy the tetravalency. Have you counted? Here you are seeing 1, 2, 3. Around each carbon, only 3 lines you are seeing here. Here 1, 2 and 3. So this is the third one. One more. Yes. Now count. Around each carbon there are 4 lines. This is how to write the structure of ethene, C2H4. What is this? This is the electron dot structure of ethene, right? Already you practiced these things. Let us move on to next one. What is this? This is ethane, C2H6. This is the electron dot structure of ethane. Observe the electrons. 4 valence electrons are there. In the valence shell, after sharing, octet is achieved. Hence, this is the electron dot structure of ethane, right? Now, let us try to write the electron dot structure of ethine. Ethine, YNE, indicates there is a triple bond. It is unsaturated hydrocarbon. What is the first step? Draw the carbon chain. How many carbons? 2 are there. Now, let us write a single bond. 2 carbons, 2 hydrogen, 1 hydrogen for each. See here. What next? Count the valencies. Only 2 valencies are satisfied. Tetravalency means still what you have to do? You have to draw 2 more. 2 more valencies you have to satisfy. Hence, draw 2 more bonds between carbon atoms to satisfy the valency. This is the structure of ethine molecule. What is this? You know, this is the electron dot structure of ethine. So, practice this one also. Now, let us move on to next one, that is the comparative study of saturated and unsaturated hydrocarbons. First property is the bonding. Saturated hydrocarbons are having only single bond, unsaturated one having double and triple bond. Next one, suffix. Saturated hydrocarbons are having ANE at the end. So, ethane, propane, butane, ANE. Unsaturated having double bond, their name ends with ENE, example ethene, propene. Then triple bonds are seen in alkyne, their name ends with YNE, ethyne. Now, the general formula for the alkanes is CnH2n plus 2. Example, ethane, where n is equal to 2, 2n is equal to 4, plus 2 means 6, hence C2H6. Then what about this one? Alkenes are having CnH2n. Let us say n is equal to 2, then 2n will be 4, hence ethene is having the formula C2H4. Then alkynes, let us take n is equal to 2, then 2n minus 2 means 4 minus 2 is equal to 2, hence ethyne's formula is C2H2. Now, example for this alkane, alkenes and alkyne series, right? So, this is the comparative study of saturated and unsaturated, or differences between saturated and unsaturated. What are these? What is this? How many carbons are there? 4 carbons. So, it is butane. What is the formula? Count the carbons, 4 carbons and hydrogens 10. I think you are writing the structures. Yes? Now, let us see one more structure. What is this? How many carbons? 4 carbons. Now, see, this is the branch. Here you are seeing different structures. What do you call them as? You call these 2 structures as isomers. They are having the same molecular formula, hence it is called as isobutane. This is the butane, this is isobutane, having the same formula. Molecular formula is same, but different structures are seen here. Hence, with respect to each other, they are called as isomers. Iso means similar, so they are the isomers. Now, the compounds with the identical molecular formula but different structures are called isomers. This phenomenon is called as isomerism. What are functional groups? They are the group of atoms responsible for characteristic chemical property of a particular compound is called a functional group. It may be an atom or a group of atoms or a bonds responsible for a characteristic property. What are you seeing here? The functional groups are derivatives of the hydrocarbon. Here one hydrogen is replaced with a heteroatom called chlorine. Hence this is the chloromethane. General name for this compound is haloalkane. So this is chloromethane, right? Now alcohols also example for this one. Alcohols, aldehydes, ketones, carboxylic acids, these are all example for various functional groups. Now let us see what are the different heteroatoms are possible. Carbon can form the bond with many other elements such as halogens, oxygen, nitrogen, sulfur and so on. What are you seeing here? Hydrogen is replaced by a chlorine atom, that is the halogen. Hence, chlorine is the heteroatom responsible for the characteristic property of this compound. In a hydrocarbon chain, one or more hydrogens are replaced by such atoms such that tetravalency is maintained. Then you will get a new compound, new functional group, right? Now, the functional groups are the derivatives of the hydrocarbons. Already you saw that one in previous slides. From the hydrocarbons, the element replacing the hydrogen is called as heteroatom or a functional group. What are you seeing here? Here hydrogen is replaced and CHO group is attached. This is the aldehyde functional group, right? Now, various functional groups are tabulated here. Let us learn what they are. Here heteroatoms are given, that is the first one is halogen, chlorine and bromine, second one is oxygen. The class of compound when chlorine bromine is there, you call that one as haloalkane. What is the example? Chlorine bromine. In alcohol, OH group is replacing the hydrogen. Aldehyde, CHO group is replacing. Ketone, C double bond O. Here ketone should be in the middle. On either side there should be carbon atoms. Then carboxylic acid found attached to terminal carbon atom by replacing one hydrogen with the COOH group. If it is COOH group, you call that one as carboxylic acid. This table is there in your textbook. Now, let us understand what is the meaning of this homologous series, very important series. A series of the organic compounds which have the same functional group that substitute hydrogen in the carbon chain, that is called as a homologous series. What are you seeing here? One is methane, second one is ethane. Already you know the structures. What I am doing, I am replacing one hydrogen with the OH. In both the compounds, you are seeing same functional group or group of atoms are replacing the hydrogen. What is the difference between these two in terms of hydrogen and carbon? That is a CH2 unit, hence it is very important hint to identify a homologous series. Now let us see characteristic of this homologous series. You are seeing the same functional group throughout the series. the heteroatom is same. Now, each successive member differ by a CH2 formula unit. Check. CH3OH and C2H5OH. What is the difference? That is the CH2 in terms of mass 14 units. That is the difference. Now let us calculate and understand. This is the formula C2H5OH ethanol. The first one is methanol CH3OH. What is the difference? A CH2. Now what is the mass of C2H5OH? Carbon is 12, hydrogen is 1, oxygen is 16. If you add, you are getting 46. Then mass of methanol is 32 units, as you studied in 9th standard, right? What's the difference? A 14. Hence, these are constituting a homologous series. Now, you are seeing the gradation in the properties, that is, the physical properties gradually showing slow increase. That is, there is no abrupt increase or decrease in the properties such as melting points, boiling point, solubility, etc. As the molecular masses increase ascent of series, that is the homologous series, a gradation in the physical properties seen. That means melting point increases gradually, boiling point increases gradually. When the mass increases, attraction between the molecules also increases. That's why there is a gradation. Now see, I am heating the molecules. Observe what happens. There is intermolecular force of attraction is broken. Now they set free. This is called as melting or fusion. Here between the carbon compounds, there is an intermolecular force is shown. If it is weak, you can easily separate them. In the hydrocarbons or any organic compounds, the melting point and boiling point is comparatively low. That means generally they stay in liquid state or gaseous state at room temperature. Methane, ethane, propane, butane, these are the gases. When the mass increases, gradually they turn into volatile liquids and then gradually they are solids. Now, the chemical properties of these homologous series, that is solely determined by the type of atom, heteroatom or a functional group present in this. Hence, they remain similar throughout the series. Chemically, they are identical. That means they show similar chemical properties. Let us perform an activity to understand this one. Now calculate the difference in the formula and molecular masses for methanol and ethanol, ethanol and propanol, propanol and butanol. Arrange these alcohols in the order of increasing of the carbon atoms, increasing carbon atoms to get a family of alcohols. Can we call this family as a homologous series? Try yourself. What is this? This is the methanol. Then second one is ethanol. What is the difference between these two? A CH2 unit. Now see here, this is what? Propanol, C3H7OH, right? The next one is, you are seeing here, this is the butanol, C4H9OH. Between each member, there is a CH2 unit difference in the sense they are constituting a homologous series, right? All are having same functional group OH, hence they are alcohols. Till now you studied catenation, tetravalency, saturated and unsaturated hydrocarbons, difference between them, isomerism, functional groups and homologous series. I hope you understood these concepts very well. These are very, very important concepts of the session. Now, let us test what we learned. Are you ready? This is the quiz time. Here is the first question for you. Homologous series differ by a CH2 unit, CH2N, CH3 and CH4. What is the answer? Answer is a CH2 unit, right? Now the next question. The next question is, the element that does not exhibit the catenation is, what is that? Carbon, phosphorus, sulfur, hydrogen. The answer is hydrogen. Ketone functional group is OH, CHO, CO and COOH. What is the answer? The answer is C double bond O. Now the next question is, when one hydrogen atom is replaced by a CHO group from the methane, you will get what? Your options are methanol, ethanol, methanol, ethanol. Out of these four, what is your choice? See the answer. Yes, this is ethanol. Now, this exhibits isomerism. What is that? Methane, ethane, propane and the last one butane. What is your answer? Let us check the answer. That is the butane. Now this is the homework time. I will give a few questions. The first question is, explain the isomerism with examples. Next question, what are functional groups? You have to give examples. Next one, explain homologous series with the suitable examples. Next one is, out of CH3CHO and C2H5CHO, which compound have higher boiling point and why? The fifth question, explain the stability in the carbon compounds. How will you explain which is the stable compound, which is less stable? Why? Catenation is responsible for the formation of millions of compounds. Substantiate the statement. How will you explain? Dear children, till now you studied very important concepts of carbon and its compounds like tetravalency, catenation, homologous series, functional groups and so on. I hope you enjoyed the session and understood these concepts very well. These are the foundation for next class. I hope you understood all these things and you are well prepared, and also I hope you will answer to those questions given as homework and you will discuss with your teachers also and you will understand those concepts very well. Then let us meet in the next class. Till then, bye bye, namaste.